To think about being able to read from phase diagrams, I was just showing you a phase diagram like this, which is a combination of, or it's a phase diagram that's expressed in terms of the temperature and the composition. Well, temperature and composition, those are two thermodynamic variables that we can work with. Turns out that these phase diagrams, they are essentially ways to represent thermodynamic data. So we aren't limited to only working with temperature and composition, but in fact, any variable that goes into your thermodynamic equations can be used. For example, this can be temperature, composition. It could be pressure. It could be magnetic field. You could have magnetic field and electric field. You could have applied stress and magnetic field. Any of those, and you can map out a phase diagram. So another fairly common phase diagram for us to show, these are called unary. A unary diagram of, say, a single compound. And one of the first two phase diagrams that we like to show is water. And if you're representing just a single compound, we can't vary the composition, but we can vary the temperature, and we can vary the pressure. Temperature and pressure. And a phase diagram of water in terms of temperature and pressure will look something like this. Or I should say any phase diagram in which we're dealing with a simple compound that goes through a freezing and then melting cycle. So at a given pressure, say 1 atm, we will have a point at a given temperature in which we are all solid. As we increase in temperature, we reach a point. It goes through melting. And now we're in a region of liquid. Keep going up in temperature, so I'm going to mark this as T melt. We reach this point, and we transition from liquid to vapor. T vaporization temperature, or boiling, which means above that we are in the vapor phase. So I'm going to try to distinguish the colors here a little bit. There you have it. So this tells us then how changing the pressure and temperature and moving to different points in that diagram, you'll know what the compositions are. Now, kind of interesting points here are that down here at this pressure, as we go up, we're going to go straight from solid to vapor. And what happens, this is called sublimation. So there's going to be T sublimation. And for example, dry ice at 1 atmosphere of pressure, it goes straight from a solid to a vapor, so it sublimates. Presumably, if you increase the pressure, at some point, carbon dioxide is going to go from solid to liquid to vapor. Other questions that people often ask are what happens if you're exactly on this line? Well, if you can control the temperature and the pressure precisely, so you're right on that line, then you're going to have both phases present. These are actually kind of special points or special parameters, that special pressures and temperatures in which you can have two phases coexisting. It's difficult to get, but you can achieve that. And in fact, this triple point, there are quite a few videos online, well, some videos online, I should say, in which you can see people trying to achieve a triple point. And I think I've seen possibly carbon dioxide and possibly water as well. They have to control the pressure and the temperature precisely in order to get this type of triple point behavior.